Okay, so today we're going to do pages 21 to 22 in your packet, which are your quiz review pages. I'm going to do every problem now in the video. I highly suggest that you either print a blank copy from Edline or from my remind.com message later and try the problems yourself. The only way you're going to know if you can do them for the quiz on Friday is if you try the problems. If you get stuck, watch the video as many times as you want. I'm going to explain every question, but you need to actually try the problems at some point yourself. This afternoon, Thursday afternoon, I will send a Remind one-on-one remind.com text message out that has the packet attached if you want to print yourself with page 21-22, and I will also include a link to this video. Okay, so by now everyone should be on page 21 to 22, and we're going to sketch the derivative graph. Now if it helps you, you can sketch this graph off on the side or in your calculator to see what the slopes are everywhere. I don't have a digital graphing calculator on my computer here at home, so I can sketch it by hand. There's y equals 3. So if you look, the slope everywhere is 0. So my derivative graph is going to be a horizontal line at 0. Now for y equals -3, it's the same kind of graph except below the y-axis, so again the slope everywhere is 0. Now when we have a line, 3 is my slope. So if you graphed this line, it would look like this, and if you counted your rise and run, you would get 3/1. So the slope at every point on number 3 is 3. So we have a horizontal line at 3 for the derivative. Now for 4, the slope everywhere is -3. So I'm going to draw a horizontal line at -3. Now for x squared, if you graph this in your graphing calculator, you are going to get a nice parabola shape. And I can't count the slope at every tangent point because it is curved. It's not linear. It's not straight. So you can use the calculate that when you're on your graph, if you go to second trace, which is the calculate menu, choice 6 is dy dx, and then type the x value. So if you type 0, hit enter, it's going to give you a slope of 0. Then go back, do second trace, choice 6, then do, let's say, 1, enter, and it's going to give you the slope at 1 is 2. And if you keep repeating this and you press 2, it's going to give you the slope is 4. And if you do -1, the slope is -2. And we're going to get this line as the derivative of x squared. Now for negative absolute value of x, that is a V-shaped graph opening down. And there's something very special about this. At the sharp point of the vertex, there is no derivative. It's undefined. So I'm going to have an open circle somewhere along 0 where this vertex happens. The slope on the left is +1. The slope is undefined at 0, and then the slope on the right side is -1. So there's the derivative graph of negative absolute value of x. Okay, so for filling in these blanks, if the original graph is something, then the derivative is positive. So that's when the original is increasing, that's when the derivative is positive. When the original is something, well, let's see, so when the derivative is negative, that means the original is decreasing. And when the derivative is 0, the original graph has a max or min. Okay, so now for 8, prove using the limit formula that the derivative of this is 2x. On your quiz, these are how the directions are going to be worded. I will give you this format, that setup. There will be no lines because they're in the way. And we're going to have to do a lot of algebra. So let's find f of x plus h. So x plus h gets plugged in for this x. Now I have to simplify. That's x plus h times x plus h. Multiply these together. FOIL or box method, distribute. And then I have some like terms here in the middle. So now that's this first part of my numerator. You have to write the limit as h approaches 0 every single time until you plug in the 0. So now I'm going to subtract the original function. And the reason I put parentheses is because you have to distribute this negative. It is necessary. So now if I rewrite everything with the negative distributed, that's minus x squared minus 3. And what I need to happen is that every term without an h should subtract to 0. So x squared minus x squared is 0, 3 minus 3 is 0, and I'm left with these two terms that just have, so I have 2xh, this is what I'm left with. So I can divide an h out of my numerator, so I'll be left with the limit as h goes to 0. These h's cancel. Now I can plug in 0, and I'm left with 2x. And that's what we needed to get. Okay, so let's do it all over again for number 9. And then 10. I'll do 9 because it has that negative. Okay, so for 9, I'm going to plug in x plus h. When you square it, that means times itself. And then minus 3 times x plus h. So I'm going to multiply these together again. And now here you have to distribute the negative 3. And that goes in the first part of my numerator. Remember, you have to write the limit until you plug in 0. And now I'm going to subtract the original, so that's going to be negative x squared plus 3x. I'm going to take this negative and distribute it to both of these terms. Okay. X squared minus x squared, negative 3x plus 3x. So we're left with 2xh plus h squared minus 3h. I can factor an h out of my numerator. I was going to take a shortcut, but I shouldn't, because I don't want you to. That equals the limit as h goes to 0. Okay, so I'm going to factor out my h. So I'm left with 2x plus h minus 3. If it helps you, you can do this to each term to help you visualize the h's reducing. These h's now reduce. I can plug in my 0, and I'm left with 2x minus 3. That's what we needed. Okay, one more time for number 10. We're going to plug in x plus h. The first one's squared, so I multiply it by itself. I'm going to multiply these together before I distribute the 2. Distribute the 3. Now I'm going to distribute the 2. Okay, so that becomes my numerator. Limit as h goes to 0. I'm just copying the algebra work I did on the right. Okay, so now it's minus, sorry, make that a different color so it doesn't run into this. So minus the original function, but because it's subtraction, it's negative 2x squared minus 3x. 2x squared minus 2x squared, 3x minus 3x. We're left with 4xh plus 2h squared plus 3h. So if we divide each term by by h, we're going to divide by h, we're going to be left with 4x plus 2h plus 3. Now I can plug in the 0, and we get our 4x plus 3. Okay, so question 11 is a calculator problem, 100% a calculator problem. This function here goes into your y1. And that's a little t next to the decimal and the exponent. When you type in that exponent, your y1 is going to look like this, 100 e to the, and you have to put the variable in the parentheses with that decimal number so that it's all considered the exponent to e. So to find the derivative, what we're going to do is in the math menu, if you scroll down to choice 8, it's nderiv. Depending on your software, you're going to have the old version like me, or you're going to have the new version that gives you these boxes. And here's what you're going to fill in. If you have the old version, you're going to type y1. You get y1 by pressing the vars button, which is near your arrows, arrow over to function. Oh no, it's not function yet. I think it's y variables and then function and then y1. And then after you get the y1 here, you're going to press the comma, which is right above the 7. And you're going to type x, just like you would type an x in your equation. And you're going to do comma, and then we want the number at where the derivative is, which is 2. You're going to get an answer around 277 bacteria per hour. Now if you have the new version, the x goes in the denominator here, your y1 goes here, and the 2 goes here. And you'll get the same answer. Okay, for number 12, not differentiable, meaning there's a sharp point. So if you graph the absolute value of x, to get absolute value, you're going to go to the math menu, the number button, now you get arrow over to number, and choice 1 says ABS. So when you graph the absolute value of x, that has a vertex on the origin, so that happens at 0. When it's x minus 2, your vertex is to the right 2. Sorry, that's not a very good sketch. That's at x equals 2. If you graph this one, your vertex is at negative 2. That's where the sharp point happens, so that's x equals negative 2. Okay, so then lastly for 13, I'm sorry I can't demonstrate this on my calculator here. You're going to graph sine x squared, and when you type that into y1, it's going to look like this. Your x squared goes in the parentheses, and you're going to hit graph and graph it, and then using the draw menu, which is second program, you're going to use choice 5 tangent, and you're going to hit 1 enter, and it's going to give you the equation, the tangent line at the very bottom of the screen, and a graph. So here's the graphs that I've drawn. So your graph should look similar in your calculator, and then the red line is what I drew as the tangent line. You can take the decimals that the equation gives you, the equation of the tangent line at the bottom. Okay, so like I said at the beginning of the video, I suggest you do 21 and 22 as practice for your quiz. I just did them all. You need to take the quiz, so you need to be sure that you can do the problems. You can do page 20 as some extra practice. The top part with the charts, that's just a bunch of calculator practice. There is the bottom part, using the limit to get the derivative. That's more good practice if you want to practice all the algebra to use the limit definition. But print yourself or look at a clean copy of page 21 and 22 and make sure you can do those questions for your quiz on Friday.